Okay, for Vignette 3, we're going to solve problem 13, section 2.1, page 58. Part 3a asks asks you to show that the map w equals z squared maps x equals 1 to a parabola. All right, well, let's just do that. We need to parameterize this line in an understandable way in order to make this work. So any point on this line can be written as z is equal to x, which is 1, plus I times y. And to emphasize that y will be allowed to vary, I will say I times t because we think about t as moving. And t moving from minus infinity to plus infinity imposes a sense of direction on this line, but that's really just because of our parameterization. Anyway, we'll think about this line being mapped by w equals z squared. So if z is 1 plus it, then w is going to be 1 plus it squared, which is 1 plus it times 1 plus it. So that's going to be 1 times 1 minus t times t, 1 minus t squared, plus I times t plus I times t. So w is u plus iv. So therefore u is equal to 1 minus t squared, and v is equal to 2t. And this is the parametric equations of the image of the straight line. And it's pretty clearly a parabola because this is degree 1 in t and that's degree 2 in t. But let's take this parametric description and come up with an implicit equation in u and v, which shows that clearly. That process is called, naturally enough, implicitization. Before, we came up with a parameterization for this line. Now we have a parametric description of the curve. Let's implicitize. And we do that by eliminating one parameter. In this case, it's really simple because t is just v over 2. I should show you a more general method to do that, and maybe I will for another example. But to implicitize this, we just say t equals v over 2, and then that implies that u is 1 minus v over 2 squared, which is 1 minus 1/4 times v squared. So it's equation u in terms of v, u is in terms of v squared. It's clearly a parabola. And we like our axes, the real axis and the imaginary axis, to be written that way. So the question is, what kind of parabola is this? Well, this is like x is 1 minus 1/4 y squared. So that's a parabola that's going to be opening horizontally. And because that is a negative thing, that says that when v is really large, u is going to be really large and negative. So that'll be over on this side. So it's got to be opening this way. And when v equals 0, u equals 1. And that corresponds to t equals 0. T equals 0 gives u equals 1 and v equals 0. And so we know that the parabola is going to be opening up that way. I'm drawing a very poor parabola, but luckily the v-axis is not to scale. Now the question is, which direction is this? I drew it going this way, but is it really that way? T increasing here, t increasing means v is increasing, so the direction is this way. So yes, we have the same direction of the parametric curve. But that's an artifact of our parameterization. The image of the line is that parabola.